calculus, we're going to be looking at derivatives today of y equals b to the x, where we're going outside of the realm of e to the x, and also log base b of x, where we're going outside of ln. So it's going to be interesting today. First little things, bunny trail before we get started, is just to recall. If I have an expression like that where I've got e and ln together, we were saying at the beginning of this unit that e and ln are opposite functions, so they would cancel. We would end up with b to the x. And we're going to keep that in the back of our brain while we do this proof for the derivatives of y equals b to the x. So if I have a function, f at x equals b to the x, from what we were just looking at, I can rewrite that, which seems like y, but e to the ln b of x. And we said that e and ln are opposites and would cancel. So I haven't done anything wrong. I've just made it look more complicated. Because I can only take derivatives base e, I don't know how to take derivatives base b, then I have set it up so that I know how to find the derivative. Also, with my rules of lns and logs and powers and whatnot, I can continue to rewrite this as to bring down the power. So if I have ln of b to the x, that's the same as x times ln b. So that's knowledge I'm assuming you have, so that you can trust me in this proof. Here I have my function, which is really b to the x, written in a different way. And I want to find my derivative. Well, I know how to find the derivative of e to the something. The derivative of e to the something is e to the something. Don't forget the guts. So the guts of x ln b is ln b. So my derivative is, oh, well, I've seen this first part before. This first part was this guy, which is really this guy. So my derivative is b to the x ln b. So the big idea today is if you have a function, f at x, that has a base other than e, then its derivative will be b to the x, adjust for the base. Because ln and e are the only beautiful ones, then if we have other powers, we have to adjust for that different base. Okay, here we go. Example number 1. Y equals 2 to the 3x at x equals 4. So my derivative is, okay, if I have a power, then my derivative is b to the x. Oh, don't forget the guts. Adjust for the base. So this is the guts. This is because our base is not e. Our derivative is approximately 8517.39 at x equals 4. Okay, next one. F at x equals 3 to the x plus 2. Our function is a power, not base e. So I've got that little adjustment I need to make for the base. So if f at x equals the power, don't forget the guts. Well, the guts are 1, so I'm okay. And I have to adjust for the base. And I want to know at x equals 1, f prime at 1 equals 3 to the 3 ln 3. Approximately 29.66. All right, one more. This is going to be fun. So y equals 4 to the 4x to the 4, because why not? So my derivative is, I have a power of 4, so I'm going to have to adjust for that base in a second. So my derivative would be 4 to the 4x4. I have to consider the guts, which would be 16x cubed, and I have to adjust for the fact that it's not base e, so ln 4. Okay, just kidding. I want to do one more. Let's do red for danger. Y equals 3 to the x4 plus 1 cubed. My derivative would be, okay, I've got a power. It's not base e, so I'm going to have to adjust for that. So let's just, don't forget that. So my derivative would be 3 to the, don't forget the guts. So I have 3 x4 plus 1, reduce it by 1. And then inside of that is guts. So it's like guts of the guts. If any parents are listening, it's going to be weird. Okay, guts of the guts. Done. That would be the derivative. We could certainly tidy that up, but nah. We are also going to look today if you have a function that is log base b of x. So we're stepping outside the realm of ln as well. So we might have an adjustment for that weird base. So what I'm going to do, just to prove to you what the derivative is I'm going to write this equation in a different form. So I'm going to write this equation in exponential form. So b to the y equals x is an equivalent expression to our original function. So I'm going to take the derivative of both sides with respect to x. So the derivative of b to the y is b to the y ln b. We did that yesterday. And the letter isn't x, so I've got to adjust for the base. Sorry, I've got to adjust for the derivative with respect to x. It's like the guts. And the derivative of x is 1. So derivative with respect to x from our knowledge of yesterday. So if I want dy dx, I am going to divide both sides by b to the y ln b. Well, I know what b to the y is. B to the y is x. So if you have a function that is y equals log base b of x, it's 1 over x, just like ln is, except that we have that adjustment for the base again. So let's do a few examples. My first example is y equals log base 2 of ugly. Okay. I could write that, I suppose, as log base 2 of x squared plus 4 to the 1/2. That can help some of us as well. Or you can bring that 1/2 out to the front, doesn't matter. Okay. If I am taking the derivative, I know that for log base 2, it's 1 over. You could write it either way. 1 over the function, adjust for the base, and then don't forget the guts. So the guts is bring down the half. X squared plus 4 to the negative 1/2. The guts of the guts is 2x. And I'm going to just tidy that up a little bit. My 1/2 and the 2 cancel. So I have x. I'm kind of working on the right side right now. That x squared plus 4 is also square root, also goes to the bottom, so I have x squared plus 4 without the root sign, ln 2. Last example, y equals log base 10. So I'm going to have to adjust for that different base. It's not ln. 1 plus x over 1 subtract x. So I have got a log, different base, and a quotient all in one. There are different ways to do this, but my thinking is I know that the derivative of log is 1 over. Adjust for that different base. Don't forget the guts. So my guts would be a quotient. My quotient rule is, here we go, the derivative of the top times the bottom. Subtract the top derivative of the bottom over the bottom squared. So that is my derivative. It is hideous beyond all reason, but I'm going to tidy it up a little bit. So I've got this fraction under a fraction, which is bad form. So I've got 1 minus x over 1 plus x ln 10 is better. And the top, I have 1 subtract x plus 1 plus x over 1 minus x squared equals 1 subtract x times, what does this all, oh, the x's disappear, times 2 over 1 plus x, 1 minus x. Ln 10. Oh, wow. I have a 1 subtract x top and bottom, so I end up with 2 over 1 plus x, 1 minus x ln 10. And if you wanted to be really pretty, you would notice that's a difference of squares. Doesn't matter. 1 minus x squared ln 10.